Hello and welcome to another installment of Ebatco Lab video. In this video we will show you a bit about friction measurements. Here in our Nano Analytical Lab we use a TS501 tribuster produced by Kiowa Interface Science. This measures the coefficient of static and kinetic friction using a horizontal linear motion system. Let's take a look. Here we see the main instrument. The unit features a translating stage controlled by the software in the x-axis for making measurements, and it also has manual translation in the y direction to offset the sample so that each test can be done in fresh sample areas. Here we see the balance head mounted on the end of the measurement arm. The balance head is where the desired contact piece is mounted and the desired load weight is placed on top for the test. A strain gauge sensor picks up the force on the measurement arm resulting from the movement of the sample under the contact point and relays that to the software in real time. Measurement conditions include weight, the speed of motion, and the frequency of reciprocating cycles. The stage can be temperature controlled with a heater type stage. This instrument can also measure with a variety of contact parts, including a round facet contact, a line contact, a flat facet contact, and a point contact. You can also request custom contact parts to be produced and used for your measurements. Most devices coming out these days have touchscreens. The overall comfort of using a particular touchscreen is very important to the end user. There are many things to take into consideration when making a touchscreen, but one that is easy to overlook is the friction between the screen and the user's fingers. Ideally, I would like swapping my finger across the touchscreen to be smooth and effortless. Today, we will be looking at the friction coefficient of a touchscreen and a simulated finger using the flat face with a silicone rubber attached. We will take a look at the clean screen, similar to right out of the box conditions. While the friction between the screen and your fingertip may not be the most crucial factor when considering a touchscreen, it is an interesting thing to consider if you wish to make a quality screen. Considering the state of the touchscreen when measuring the friction is also important. Controlling the friction on the screen is all well and good in laboratory conditions, but when it's out in the real world and covered in greasy fingerprints, it's a whole different ballgame. Controlling the friction can make browsing on the tablet a breeze, or can even make typing on a screen-based keyboard easier for everyone. Today, we will be looking at the friction coefficient of a touchscreen and a simulated finger using the flat face with a silicone rubber attached. We will take a look at the clean screen, similar to right out of the box conditions. We will begin by placing and securing the sample on the stage. After, we will slide the weight onto the measurement arm above the sample. Once everything is ready, press start. The start button will flash to show that the test is running. You can see here that the tribuster translates the stage from left to right and records the observed force experienced by the sensor. It then reports both the static and kinetic friction. To make another measurement on this sample, we simply need to relock the sensor, lift the arm into the raised position, and then translate the sample in the y direction to move the measurement area to a fresh location. From the data table, we can see that for this pass, the static friction coefficient is given as 2.413, the kinetic friction is given as 2.180, and the minimum and maximum kinetic friction values are given as 2.318 and 2.019 respectively. This is a graph of our results. The static friction is measured at the highest value before the blue vertical line. Kinetic friction is the average of the values between the vertical lines. That's all for this installment of Ebatco Lab TV. We hope you enjoyed and will visit us again. Keep an eye out for more videos covering diverse topics from our lab. If you have any questions about either the methods or the instrument you saw here today, please don't hesitate to give us a call or shoot us an email. Our contact info can be found on our website. And as always, if you're interested in nanoscale material and device surface characterization lab services or consultation, please contact us. We'd love to hear from you.